Okay, so we have a polynomial here, and we're being asked to factor it. Um, Certainly, I'm not going to say you can't do it just by looking at it by trial and error, but the problem is it's not an easy pattern to recognize. So what we do is we use what's called the rational root theorem. And the rational root theorem, what we do is we look at the factors of this, divide by the factors of the coefficient on the x cubed term. All right, so I'll write that down for you, and that will be plus or minus. It's going to be the ratio of the factors of 12, this guy here. Well, the factors of 12 are going to be 1, 2, 3, 4. Wow, there's a lot of them, isn't there? 6, and 12. And certainly the factors of this over here, which coefficient of 1, is just 1. Now, certainly when I say plus or minus, I'm saying that, if f of x, let me put this over here, equals x cubed plus 4x squared plus 7x minus 12. If this has a rational root, it must be from this set over here. So if someone says, what is that set? It's a fairly easy set of numbers. I'll write them down for you. It's going to be either plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. So, again, if it has a rational root, it's got to be in that list. Here comes the problem. It's a large number of numbers to test out. So what I'm going to say over here is I don't want to test them all. I want to test the easy ones. And I hope I'm going to hit it really quickly. So what I'm going to claim over here, just kind of looking at it, making a stab at it, I'm going to say the easiest number on that list would be to try 1. So I'll put this down. And if you try 1, what do you get? You would get 1 plus 4 plus 7 minus 12. And if you look at that, 1 plus 4, 5, 5 plus 7 is 12, and 12 minus 12 is 0. So right now, what I know that 1 is a root. Therefore, I know x minus 1 is a factor. Now, I realize what someone could say, you're going to test the other ones? Absolutely not. What I'm going to do to get the remaining factor in the problem, I'm kind of done with this, is do a long division. Let me just go through that with you briefly. So I would take x minus 1. It should be very simple to do, by the way. There's a guaranteed, this is from the remainder theorem, that this will have a 0 remainder. So what do you have here? X cubed plus 4x squared plus 7x minus 12. And I'll divide by x minus 1. Long division. What do you get? Let's see. You get x squared. What do you get there? You would get x cubed minus x squared. You subtract. That gives you 5x squared plus 7x minus 12. This will go very smoothly, by the way, plus 5x, which gives me 5x squared, all right, minus 5x, subtract, you get 12x minus 12. And then, what times x would give you 12x? Fairly simple. It's just plus 12. What do you get there? 12x minus 12. As stated, 0 remainder. So I know the other factor. It's quadratic in form. X squared plus 5x plus 12. All right? Let me erase my long division. And I want to point out, if you look at this thing over here, it's, the quadratic's much easier. If it's factorable, much easier to factor. I hope you realize no matter what you do on this, you're not going to get it with finger numbers. It's x and x. And the only choice I have for 12, it's got to be positive, positive. 2 and 3. I'm sorry, 2 and 6, 3 and 4, 12 and 1. You're never going to get a 5. Now, I realize what some people may ask, is it factorable? It is factorable. We haven't gotten to that stage yet, though. And what I mean by factorable, you'll be able to factor that into 2 linear factors. But right now, we can't do that. So I'm going to say this is my answer. And the answer is written right over here. X minus 1, x squared, plus 5x plus 12. Exactly what we got over there. We're using a rational root theorem. Thank you.